Hey, in the last tutorial we developed the push and pop operation for the integer stack, and the stack was a fixed kind of stack. It was not a dynamic one. You can see that we had defined this macro for the size of the stack. The array was declared with that size macro, so it's always a fixed sized array. Now in this tutorial I'm going to make it dynamic. For that, let me just declare a pointer here, and for a particular stack we will be allocating this array dynamically. Since a different stack object is going to have different size, so we need to keep track of the size of the stack object as well. So let me just declare a variable size within the structure. Instead of the macro, now the size is a variable for a particular stack, and that will be kept within the stack as well. So now in the init method I'm going to allocate the stack array. So the init method is now going to receive the size as well. So the prototype of the init method is going to receive one integer. That's the size for the array. So we are going to allocate the item array dynamically using the malloc function in this case. We know that malloc can allocate dynamic array in runtime. So it's going to be size of integer multiplied with the size. So if the size is 10 elements, then it's going to be allocated dynamically 40 bytes, because the size of integer is going to return 4 for integer type, and this is the size that we want the stack to have. So altogether, if the size is 10, then it's altogether 40 bytes. The malloc is going to allocate 40 bytes for the item array. And let me store the size as well within the stack object. It may happen that the malloc function may fail. The requested memory may not be available during the runtime. So if the item is null, that means if the malloc returns null, then the memory allocation failed. In that case, we are just printing an error message and terminating the program. So if the memory allocation fails, we are terminating the program using the exit function call. The exit status should be 1 because it's inappropriate termination. Now in this case, for allocating the stack dynamically, we should pass on the size of the stack to the init function. So it's now going to be 10 element stack and it's dynamic. So if we want to allocate 50 elements stack, so we can just pass on 50 here, and let me just allocate 3 elements stack. So I'm running the program. Okay, now the size macro is not defined there. We have taken the size inside the structure object. So here it should be actually sp arrow size instead of the size macro. That's the size inside the structure object. So let me go ahead and run the program. So it's now 3 element stack, so I can just go on and push 3 elements. Now if I try to push one more element, it's going to be overflow. You can see that it's overflow now. Let me do the exit now. Okay, we're done with the program. Now since we are allocating the memory dynamically, it should be our responsibility to deallocate the memory as well. We should write a mechanism to deallocate the memory when our job is done. So I'm just writing another function, deallocate. That's going to receive the stack pointer, and it's going to deallocate the dynamically allocated stack array. So here we should write the prototype, and it's going to receive the stack pointer. The purpose of the dealloc function is to deallocate the item array in runtime. So it should be actually if sp arrow item not equals to null, then we should free this array using the free function call. Both of these, malloc and free, are declared in stdlib.h, and we have included that in our program. Now this is totally dynamic. That means we can allocate a stack with our required size. We can have another stack with a different size altogether. So we can declare another stack s2, and we can call the init function for s2. and we can pass on a different size. Say I want to allocate S2 with say 100 elements, then this init call is going to allocate S2 with 100 elements. So at the end of the program, we should call the deallocate function in order to deallocate the stack. So when I'm exiting the program, that means here we are terminating. Prior to that, we are just deallocating the stack. Now it's dynamic, but there is one more modification that we need. While the overflow happens, it is saying that stack is overflow and it is returning to the caller. Here you can see that we have checked the overflow with size -1, but we can just modify this section. Now when overflow happens, we can just grow the stack dynamically, retaining the existing value. Each time when the overflow is going to take place, we will double the size of the stack, and that will make it more dynamic. So in the next tutorial, I'm going to develop this program further with that idea. For the time being, thank you.